COMP1511 Hi everyone who's in the room. It's great that you've come along to the in-person lecture. Hi everybody at home watching on YouTube. Hi to people in the future watching the recording. So yeah, this is the first lecture. We've got a few people still coming in, but we'll get started anyway. So yeah, for a lot of you this might be your first day at uni maybe. Hands up if it's your first day at this uni. Yeah, quite a lot. So welcome to the uni as well. Hands up if it's actually your first class at uni as well. All right, so for a lot of people, this is their first class at uni. All right, I hope it's a good one for you. All right. So today, we're just going to start off with some welcomes and some introductions. We're going to talk a little bit about how the course works, some like admin-y type stuff, how to get help. Then we're going to start talking about what programming is. We're going to have a look at Linux. We're going to have a look at C. If you're thinking, I don't know what Linux or C is, that's fine. That's what the course is for. All right. So let's get started. And feel free to put your hand up and ask questions if you're in the room. There's also, whether you're in the room or at home, there's a live YouTube chat that you can ask questions in as well. So yeah, feel free to ask questions when you like. We've got some lecture moderators over there. All right, so yeah, I forgot to say, I'm Angela, I'm the lecturer, and that's my kitten Oscar. I just wanted an excuse to put a photo up because he's cute. Yeah, you'll probably see me drinking a lot of kombucha. It is just kombucha. And yeah, that's about it. Oh no, I've been teaching at UNSW for a while over the years, so I've taught this course before and I'm looking forward to teaching it, but I haven't taught it for a little while. I'm looking forward to teaching it again this term. All right, so we've got about 1,100 people in this course, so it's a huge, huge course, and we've got an amazing team of admins who have helped put it together and get it ready. And Sophia, and Ibi, are sitting over there in the audience. So there's Sophia and Ibi. So thank you very much for helping set everything up. And throughout the term, they may also be your tutors, but they'll be helping me and all you guys throughout the term. And Nicole and Daniel, who aren't here right now, but you'll see them around. We've also got, sitting where you see that camera, you'll see our lecture moderators and streaming team. We've got Brianna. She'll be answering, along with Sophia and probably Ibi today on the chat, I'm not sure. They'll be answering your YouTube questions. And we've got John and Tim who are doing the streaming. So again, we've got a huge team of people here. And we've got about 52 tutors, I think. So you're going to meet your tutors this week in your first tut and lab. So for some of you, that might even be this afternoon. If you want to go and have a look at and find out more about them, you can go and look at Meet the Team page. So there you go. I'll let you look at it in your own time. But all of our tutors are up there. Okay. So that's a little bit about me and the team. A little bit about COMP1511 and COMP1911. So it's a combined course, but it's pretty much the same course. We'll talk about the very minor differences later. But we're here to teach you the fundamentals of programming, which is kind of the name of the course. What does that mean? The main emphasis is on how to approach and solve problems. So we want to do a lot of problem solving. And to do that, we're going to be using a programming language. And we call this sort of a common language that we share with the computer. So we assume no prior knowledge, and you don't need to have had previous experience programming. So, well, yeah, when I started the course myself many years ago, I think it had a different code. I had never programmed before, and I had never used Linux. And I heard lots of people talking about things, and I thought, oh no, everybody knows everything, and I know nothing. What am I doing? What was I thinking? But it didn't matter, and most people, the majority of people won't be programming experts here, right? And everyone's here to learn, so don't let don't listen to other people and think, oh, they know everything. Just focus on learning it yourself. We're here to teach you everything you need and help you. So yeah, don't be discouraged if that's you, because I think I wasted a lot of time worrying about that. All right. And yeah, the key thing is just to stay up to date and do practice along the way. All right. I'll just mention this code of conduct. So this course and the university, we want to provide an equitable environment. We want to allow everyone to learn regardless of their background or situation. So make sure you're not hindering anybody else's learning. Be mindful that anything connected to 1511 or 1911, the course, even on social media, you need to follow respectful behaviour, okay? So we don't tolerate any kind of discrimination, inappropriate behaviour, harassment, bullying, aggression, sexual harassment, and we want everybody to treat everybody's privacy with respect. So, yeah, sorry to be getting these sort of heavy things out of the way so early, but we just want to treat everyone nicely. And generally everybody does, so that's great. If you do have any problems, let me know. We've also got grievance officers. We want everybody to feel happy and safe and, you know, supported. All right. I've told you about us in the course. We want to know a little bit about you as well. So we're going to play a getting to know you game. It's okay. We're not going to be catching each other or anything like that. We're just going to do a Kahoot. So has everyone done a Kahoot before? All right, so get a device ready. While we're setting up, if you haven't already said hello to the person next to you or behind you or in front of you, say a quick hello while we're waiting to get the Kahoot set up. And everyone at home too, join the Kahoot. I'll just give people another, say, minute to join. Everyone joined in here that wants to join. Everyone at home, I hope you've joined if you wanted to join. A few more people. It's hovering around 4:40. All right, let's get started. Oh. I don't know where my music is. Okay. All right. So it looks like we've got quite a bit of people have written, "This could be fun?" ? Okay. I was hoping everyone was going to write super excited, but that's okay. We've still got a lot of those. All right. I don't know if people still watch TV. If you don't, you can say none. Well, we don't watch TV. Okay. So we've got a lot of people that don't watch TV in the course. I thought that might be the case. And Breaking Bad, which is awesome. And Friends. All right. Okay, let's move on. Is there anything weird in here? Okay. Wow. So we've got more people drinking water than coffee in the morning. So that's pretty awesome. Very healthy. Okay. People still listen to music though, right? Okay. So yeah, pop, which is my favourite genre. All right. And R&B and soul is followed close behind. Not that many country lovers. All right. Read minds. Okay, cool. Next. Okay, I'm interested to see this one. I was not expecting none for that one. All right. Very interesting. Okay, everyone wants to go everywhere. That's cool. Okay. It's a pretty even mix. All right, last question. Hey, where's it gone? Okay. All right. So that's really good that a lot of people wrote knowledge. High distinction, money. Okay. Yeah, good luck. Hopefully we'll get some knowledge. All right. All right. Thank you so much for doing that. It's really good to know that most of you won't be wasting time watching TV or playing video games, and you're all going to be able to focus on your computing work. All right. How do I get back to this? All right. So, yeah, back into the course admin kind of stuff. Hands up who's already been to this website, our course website. I hope everyone has. If you haven't, go there, bookmark it. That's where everything for the course lives, all the links to lecture, like to the YouTube live stream and recordings, links to lecture slides, links to tutorial questions and lab problem set questions, all of that sort of stuff. I'm going to go through some of the important things from the course outline in this lecture today. but also go and read them in more detail. So read the relevant one. If you're COMP1511, read that one. Otherwise, if you're COMP1111, read that one. The other thing that's really important that's on this website is the forum. Hands up who's gone to the forum. Okay, there's lots. Make sure you do. You should have got an email inviting you. And when you go to the forum, you have to log in with your ZID. There's also a little part in here about me where you can introduce yourselves. And I was having a look around there last night, the night before. It seems like lots of people like to play badminton. So we could end up with some kind of COMP1511 badminton team, I don't know. Yeah, so we don't use Moodle. There's no Moodle website, just this website. Make sure you've got a bookmark. So the course format, I'm going to talk more about all of these things in more detail. Obviously, we've got 2 2-hour lectures a week. Everyone should be going to 1 Tute lab, which is a 3-hour block each week. We're going to have 2 assignments and 1 final exam. I'll talk about it in a bit more detail. So the location of the live lectures is Ainsworth GO3, which you've all sort of worked out because you're here, or live streamed on YouTube, which you've all worked out if you're live streaming now. Monday 11 to 1 and Thursday 11 to 1. You go to both lectures. It's not one or the other. Week 6 for the uni is flex week, so we don't actually have lectures then. But every other week we're going to have lectures, 2 2-hour lectures a week. Yeah, you can get the lecture slides and the lecture code from the course website, and they're both really important resources. You'll be able to watch recordings later from YouTube. I've already said this, if you've got a question during the lecture, put your hand up or ask in the YouTube chat. And also, yeah, be respectful. Don't be too noisy in the room because other people are trying to listen, and we're live streaming it as well. It's different if we're doing a Kahoot. That's all right. And be kind to one another in the chat and the course forum. Just be respectful, be helpful to one another, and in person as well. So what's a tutorial? A tutorial is just like a 1-hour interactive classroom lesson, a bit like a school lesson, I guess. You can get the tutorial questions in advance, so we encourage you to read through those questions in advance to get the most out of your tutorial. You'll either be online or face-to-face. You should hopefully already know that. So check your timetable to work out what room you go to. If you're online, you'll be on Teams. And if you're not sure how to access your online class, please let us know. I'll show you the email address to use. Again, online people, if you can turn your camera on, please do. When you're on Teams, we're not going to force you though. If you've got pets running around in the background that are quiet, we love that too. So have your cat or your dog there or whatever else you've got. Directly after the tutorial, we've got a 2-hour lab. And the tute and lab are really, really important aspects of the course. And especially the lab. This is where you do some hands-on programming and coding. And that's really the best way to learn programming, is to actually write programs. So most of the lab exercises will be individual. We will encourage you also to do some pair programming, where basically you get into a pair and you program together, and your lab demonstrators will organise that for you. But most of the coding will be individual. This is also a really good time to get one-on-one help from your tutors, or discuss, how you're going with the course with your tutor. So for the labs, except for the week 1 lab, you're going to do the lab exercises and you're going to submit them, and they're worth marks. So each week it's worth about 2 marks. And in total, I think you can get 16 out of 15, but we cap it at 15. And to get the marks, you need to do the labs and then you submit them. So you'll see that during the lab, and your lab demonstrator will help you. There are some 3-dot challenge questions. I'm not sure if they're in the first week, but there are 3-dot challenge questions which are actually quite tough sometimes. Some of them aren't so bad. So if you see these 3-dot challenge exercises and you can't do them, that's okay. I think very few people will be able to do all of them, if anyone, I'm not sure. It depends, it just depends. But you might not be able to do any of them, and that's okay. They're for bonus marks. Those bonus marks can make up for weeks when maybe you missed an exercise or something like that. But they're for people that really want a super challenge. You know, they're not really, the marks you're going to get from them aren't what's important. It's the challenge. If you can't do them, don't panic. Yep, we've got a question. Hi.
What means 3-dot challenge exercises?
You'll see them when you go to the lab. When you go to the labs, I can quickly show you, right? I think.
I'm not sure if there's any in the week 1.
There might not be in the week 1 yet. When you get to the week 2 labs, but you can ask your lab demonstrator. I just want people to know in advance, don't panic. They're meant to be really tricky. Some of them are a bit like puzzles or brain teasers and stuff, okay? Yeah, it's all right. Tutes and labs also don't run in week 6 because it's flex week. All right, any other questions about that? All right. So as well as these weekly lab exercises that you're going to be doing to help practice and learn, we've got 2 assignments, and these are also other really good ways to learn computing by doing these assignments. The assignments are a little bit bigger problems, and you know, you're able to apply your skills to a sort of fun, hopefully challenging scenario. There's 2. One's released in week 4, which is kind of soonish, I guess, and is due in week 7. One's released in week 8 and due in week 10. So these are things you'll work on over a few weeks. And there's the standard UNSW late penalties that apply to those assignments. 5% per day. For us, it's off the ceiling. Maximum 5 days late. All right, but we can talk about all of those details when the assignments come out. Yeah, the tips for assignments, and you've probably heard every teacher you've ever had say this, but start them as early as possible. If you start them early, anything you come across that you don't understand or can't do, you're going to have time to get help. If you're there the night before, you'll be kind of panicking and crying if you've left it all to the last minute. All right. You'll have time to take breaks and not be just sitting there the whole time racing the clock, and it won't be so stressful. If you have trouble getting started on things, lots of students do, you can get overwhelmed or stressed or just not know where to start, come and tell us and come and ask us to help you get started, okay? We've all been there where we've felt overwhelmed and haven't been able to get started on something. We're here to help you. Oh yeah, also don't plagiarise. I'll talk more about plagiarism in a minute because we do have plagiarism detection software. That's not the only reason not to plagiarise. What's the other reason not to plagiarise? Yeah?
But you are just lying to yourself, you aren't going to learn.
Yeah, if you don't do it yourself, you're not going to learn. So it's like if you were training for a marathon and you got your friend to wear your Fitbit and, you know, you're showing up and showing your trainer, look at all the steps and the miles I've run, and you haven't done it. You're not going to get fitter. You're not going to be any good on the day of the marathon. Same with this. If you're not doing it yourself, you're not going to learn the skills. You'll struggle in the final exam, and you'll struggle with future courses, and you'll struggle out in the workforce. So, yeah, just get help and do as much as you can to learn. Yeah, so we do have a 3-hour final exam. It's in person. You can't do the final exam online. It's 3 hours, and there'll be C programming questions. We've got exam hurdles, so there are a few competency-based questions in the exam. Again, we'll talk more about this towards the end of the term, but some people like to know these things up front. So we've got these things called hurdles. There's an array hurdle for COMP1511 and COMP1911. there's also a linked list hurdle just for COMP1511. If you're sitting here thinking, I don't know what an array or a linked list is, that's fine. You're not meant to. We're going to learn that in the course. Okay. But this is something you can refer back to. All right, so here's the scary plagiarism talk. So plagiarism is the presentation of somebody else's work or ideas as though they're your own. So any kind of cheating in this course, you will get penalties. So that might be losing marks for the assignment, getting 0 for the assignment. At worst, you might be asked to leave UNSW. So please don't plagiarise. It's really traumatic for you if you get caught. It's traumatic for me having to catch you, or, penalise you. So please don't do it, and you cheat yourself out of learning. What about collaboration? So if you've got an individual assessment like an assignment in our course, collaborating and doing it with your friend is not okay. You're both going to end up submitting the same or similar work, and it's going to get flagged for plagiarism. So don't use other people's code. Don't email your code to a friend who promises they're just going to read it and not copy it. It's happened so many times. Don't upload it somewhere publicly, okay? And if you realise you accidentally did that, tell us straight away. Take it down, but tell us. But just try not to do it. That includes posting your code in the forum, right? For the 1,000 other people in the course to copy. Okay. And then some people ask, what about as a professional programmer, you might go onto Stack Overflow and look up something and grab a few lines of code. Yeah, if you're grabbing 2 lines of code from Stack Overflow to do something very specific, you can do that and in a comment say from Stack Overflow and reference it. But if you're downloading a whole assignment or whole chunks, it's not okay. Yeah?
What if 2 people coincidentally wrote the same code?
They can't. It's just too. It just can't happen, and because the programs are complicated enough that it just doesn't happen. Yeah, people make different choices and do things in different orders, in different ways. Yeah.
To reference code, instead just hit the URL.
Yeah, you could paste the URL in a comment. Yep, and say I took these 2 lines or whatever. Yep.
Can I get reviews from the teacher? Like, hey, why is this code not working? I think this logic should be running, but it's not.
Yeah, absolutely. So there's plenty of help that you can get from our teaching team. So that's the help we want you to use. And I'll tell you about all the different help avenues in a minute. So yeah, that's a very good question. So overall, this is the assessment. Labs 15, assignment 120, assignment 225, final exam 40. To pass the course, you need to, when we add all that up, you need to get 50 or above, and you also have to pass the exam hurdles, which I spoke about before. All right, some of you might be wondering what's the difference between COMP1911 and COMP1511. Not much. COMP1911 is for people who aren't computing majors, who probably are going to go on to do COMP1521. It's not a prerequisite for other comp courses. We pretty much have the exact same course. The only 2 slight differences are that when we do assignment 2, COMP1911 students won't do the final 1 or 2 stages. In the exam, they've got 1 less hurdle. Okay, and if you've got more questions about that, please ask us. For the majority of you, this really isn't going to make a difference. Okay, just a few more things to go with all of this admin stuff, and then we'll have a break and start with programming. Sometimes during the term, you might get sick unexpectedly, like catch the flu. You might break your arm, something. I'm hoping nothing like happens to anyone, but this can happen during the term. If that happens and you need an extension on an assignment, or you're not going to be able to sit for the exam, you need to apply for special consideration. So likely need a medical certificate for a medical reason. So this is just for a short-term unexpected problem that's going to interfere with your studies. You apply for special consideration as soon as you can. So you can't come back 3 months later and do it. You've got to do it, I think, within a few days. Special cons, within 3 days. All right, so yeah, we don't want you turning up to a final exam sick. You're not going to do well and you might spread your germs. So yeah, we encourage you, if you are sick, please stay at home. If you need special consideration, get it. So again, if you are sick on the day of the exam, you would apply for special consideration and then you might be granted a supplementary exam. It'd just be an exam identical in format, but obviously different questions. For this course in this term, I think the sub-exam's in January or February next year. We don't have an exact date. Again, I'll get back to you later, closer to the exam with those details. Yep. Yeah. And I'll give you the course email address as well in a minute. Yep.
For missing exams and extending assignments, that's fine, but like, what about missing entire lectures because of it?
Entire lectures.
Because you said
Oh, well,
information that you don't.
the lectures are all recorded. Yeah. So you can catch up. But if the issue is you've been sick for such a long time that you've missed a lot of lectures and you can't keep up or something, you know, that because you're very sick, that could be a special consideration thing. Yeah. All right. Just one more thing about the exams. When you turn up for the exam, you're kind of saying, oh yeah, I'm healthy and well today. You can't then 3 days after the exam say, actually, I was sick and I had a headache, and do special consideration then, all right? If you feel sick in the middle of the exam, put your hand up and let somebody know. If you're sick before the exam, yeah, don't come. All right, equitable learning plans. So some people have conditions that aren't just unexpected and acute. They're sort of more chronic, longer lasting medical conditions or sensory sensitivities or other issues that they may need some adjustments in the course to help them do their best. They can go and apply for an equitable learning plan. So I definitely encourage you, if you've got some sort of longer term issue, please go and get an equitable learning plan, and we can make little adjustments to make your learning life better. Okay, if you've already got one, please email it to me and we can get working on what these little accommodations are. Okay, so this is a really important one. Where do you go to get help in this course? Well, you can, about the course content. You can ask in lectures in the lecture chat. You can ask in your tutes and labs. And a big one is the forum. That's available 24/7 that you can ask questions on. When you go to post your question, do a quick search. Somebody might have already asked that question, and then you can just read the answer straight away. Otherwise, post the question. Feel free to answer other questions. Be respectful and kind when you're answering questions. We'll have tutors on there that go in regularly to answer questions. They may not be answering your question at 2 a.m. They may be, but they may, give them a chance to answer it. Don't post your code publicly there. And I showed you the forum before. Make sure everyone you go visit that forum, and sometimes we have announcements there that you may not get by email, so go there and set your notifications. Now you can also get face-to-face help. We've got some optional classes called help sessions. These are where you can just turn up, walk in and get help in person or online from a tutor. So these are optional. You go along if you need them. And we'll announce that schedule soon. They'll be starting around week 3. So they're called help sessions. We've also got something slightly different called revision sessions. These are sort of like group classes to revise certain topics. So if there's some topic that you're sort of not understanding you want a bit more revision on, you can go to these special revision classes. They start around week 4. We'll put the schedule up. All right? So these are all the ways we want you to get help in the course. Now, the other thing is, if you've got questions about admin, you can email cs1511@unsw.edu.au. Me and the team of admins will be answering it. Sophia, what's an example of something they might ask?
An example of something they might email us about. I'm waiting for special cons for my exam.
Oh, right.
You're running into issues. Maybe you want to switch tutorials.
Okay.
Anything admin-y.
Yeah, anything. So just Sophia just said, for people at home, anything admin-y, but like if you've applied for special consideration and you're trying to follow up about that, or if you wanted to switch tutorials, something like that. Struggling in the course and you need some extra help, you could let us know at that email address as well. If you've got sort of major enrolment issues about enrolling into courses, and you're probably already through that sort of mess, but you email or you contact the UNSW Nucleus Student Hub. If you've got CSE course account issues, you probably don't know what a CSE course account is. I'll show you later. You go to this place for help. And because a lot of you are new to UNSW, I've just put this in. There's a whole heap of services available at UNSW: mental health services, student support, equity, diversity and inclusion, academic skills, all of these different things that are available. So I just want to make sure you're aware of them and you go and access them if and when you need them, all right? Okay, we're going to have a quick break for 10 minutes. We'll come back at about 5 past, and we're going to start doing some actual programming and course content. Okay, so come back in 10 minutes. everybody. Welcome back from the break. Everyone. Thank you. All right, I hope you had a nice 10-minute break. We're going to get into some actual computing stuff. There's a few bits and pieces of terminology we'll quickly talk about. It's not the sort of course where we're going to ask you in the exam, what does this mean or what does that mean? But it's helpful as we're talking about things if you know what the terms mean. Now, you might laugh at this question, but what is a computer? Yeah? Have we got...
Well, it's a machine you instruct, so it can give you the result you want.
Okay, so it's a machine. Yes, that's awesome. And you can instruct it. Yep, that's right. And because you can instruct it, it can do lots of different things. So it's very versatile. Actually, that was a really good answer. That sort of says quite a few of the things that I have on my slide. But even though that seems like a sort of basic question, it's actually kind of hard for most people to answer. All right, so it's a machine that can be reconfigured for different purposes. It's a versatile tool. The key elements in a computer are a processor that executes commands and memory to store information, data. Okay, so they're the key components. All right, the next thing is, what's programming? I'm just going to give you the... Oh, yeah, we've got an answer.
For providing the computer specific orders, like instructions, how they work to solve a problem or issue.
Yeah, that's right. So providing the... that's a great answer. Actually, can we have chocolates for the people that gave fantastic answers? Oh, and can someone just shut that door? There's people having too much fun out there laughing. Thanks, Sophia. All right, so the answer basically was programming is providing the computer with the instructions to do things. So yeah, it's providing a computer with specific instructions to solve a problem and using specific languages to write those instructions. And that's what we're going to be doing in this course. It involves a lot of problem-solving skills. So you might find that when you get presented with a problem, you might have to sit down and work it out with pen and paper before you just launch in and start typing. It requires you to do testing and debugging, running your program and checking that it works in all sorts of situations, and then tracking down any mistakes or bugs that you find. And you might have to go through lots of iterations to get your program right, or as right as you can. So you need to get used to the idea that mistakes and bugs are normal. Even if you're the best programmer in the world, you know, there's typos, there's just bugs, there's things that are going to happen. And you're going to have to do some debugging. So sometimes you're going to need some patience and some perseverance and just practice. The more times you make mistakes, the better you will be at fixing them and you'll learn from them. So don't be ashamed of your mistakes. And I'll make lots of mistakes in these lectures just to make you feel better about it. What's a programming language? Well, let's just talk about sort of the difference between computers and humans. So computers have to execute or can only execute very precise instructions encoded in binary. So this is what the computer processor understands, all these noughts and ones. Now, if we had to write code like this, for the sophisticated types of software that exists today, that would just be, oops, I forgot to close Teams. No, that's my fault for not closing it. All right, sorry, there's a mistake already. So, yeah, if we had to write everything in noughts and ones, this course would be, and programming would just be a nightmare. So we're not going to write in noughts and ones, but the languages that humans speak in, so natural languages, English, French, Mandarin, whatever, none of them are precise enough for a computer to understand. There's too much ambiguity in everything that we say. So programming languages are somewhere in the middle. They're precise enough that they can be translated without ambiguity into noughts and ones for the computer to understand. And hopefully they're simple enough for people to understand, at least after doing this course, you know, we'll see. So that's what a programming language is. Does anyone know what an operating system is? Yeah?
So that the computer runs on?
Yeah, it's a system that the computer runs on. That's correct. What's everybody's favourite operating system?
Windows.
I can hear lots of Windows and Macs. Does anyone use Linux already? Okay. A few Linux users, that's great. We're not expecting that everybody knows what Linux is or has used it. Okay. So just going back to operating systems, so our computers nowadays have hundreds of programs executing at the same time. Back in the old days, they didn't. They just ran one thing at a time. But, you know, you've probably all got, I don't know what you've all got running. I hate to even think. But we've all got lots of programs running at the same time. So just think of an analogy. Imagine if you had hundreds of people in a kitchen all trying to cook. What's going to happen? If no one was in charge, you'd end up with chaos, mess. You'd have people pushing each other out of the way to use the oven. The reason we have one of the reasons we have an operating system is to stop this kind of chaos happening with all of our different programs that are running at the same time. We don't want one program that you're running stealing the data from your bank account that you've got open in a tab on your browser. We don't want, you know, one of the programs hogging all the resources. So we have an operating system to take care of all of that. It also means you don't have to understand all the exact specifications of your hardware, right? You don't have to learn the exact hardware that you've got and then the exact hardware that somebody else has. If you know Windows, they've got Windows, you're all good. All right, so we are going to be using Linux. It's open source, which means it's like free to use, it's reliable, it's lightweight, like you don't need the best, like you don't need the most hardcore powerful machine to run it. It runs on lots of different things. It's very secure as well. And when we're running Linux, we're going to be using this. Does anyone know what these little screens are called that they're typing into? Yeah? Yeah, lots of people just said terminal. Awesome. So we're going to mostly be using the terminal in this course. Does anyone know what movies these pictures are from? Matrix? Yeah, one's from The Matrix. The other one is from...
Jurassic Park.
Not Jurassic Park, but good. Good guess. Yeah, it's from the 1990s Hackers, the one on the left. Anyway, with Angelina Jolie in it. Doesn't really matter. Now, we're going to be using terminals in this course because it allows you to really understand what's happening, you know, rather than just clicking buttons and dragging things around. You're seeing what's really going on. It gives you sort of more fine-grained control. And when your family and friends see you doing it, they're going to think you're really cool, right? Or really nerdy, or, you know, both. So yeah, this is a terminal. This is the terminal you'll be using and seeing when you log in. It's the window you drag around. It's got a little program in it called the shell that is, you know, you type something in, the shell looks at what you've typed in and goes and executes that for you and gives you back a response. So the shell is the little program that's running in this window. This thing here is called a prompt. So yours will look a bit different. This is my ZID. It's telling me what machine I was on. This little thing here is called a tilde, this wiggly line. This is like home, like our home directory or home folder or whatever you call it. This dollar is the actual prompt. This means, you know, you can go and start typing something in now if you see that prompt. Who's sitting here thinking, help, I don't have a Linux machine? Okay. Don't worry, we have one for you. Who's still thinking, help, I don't have a Linux machine? Okay, cool. So we've got one. When you go to your face-to-face classes, we've got computer labs with actual physical Linux machines you log into. But even if you're on your own device, we've got virtual machines that you can remotely log into and access. We've got this thing called VLab. So 24/7, wherever you are, whether you're on a Mac or Windows, you log into this virtual machine and you're on Linux with your own account, with some storage space and with all of the software that you need for the course. All right? And you'll get some instructions on how to set this up in the first lab. So when you go to the lab, your tutors will help you. You can look in advance at this link. You've just got to download a couple of things. I'm going to show you here today running it, okay? So I've already done the steps of downloading things. But yeah, I'm here on a Windows machine. I'm going to run this thing called Tiger VNC Viewer that you're going to download. I'm going to type this special magic in right here to connect me to the CSC VLab server. Don't worry if you can't see it, it's going to be in the documentation. And I press connect. So you'll see something like this, and you'll type in your ZID, and you'll type in your password, like your ZPass. Oh, shivers, hang on. Good. And you're going to be logging in for the first time. You might have an extra box or something to read a message in. But when you get in, you're going to see something like this. Looks kind of like a normal desktop, right? How do we get one of these terminal things to type into? Well, down in the dock, there's a picture of this terminal, and I can click it. Mine is, I've set it to be white with black text, not black with green text, but it's the same thing. All right, so this is logging into VLab. This is how you can access things from home. The other thing that you'll do just once in the lab is you'll run this I can't type 1511 setup. You'll just do this once and it'll set things up to be able to run everything nicely for this course. I'm not going to press enter because I've already set things up. And once you've done that, you're ready to go. So the next thing is, what on earth do we type into this terminal? So we're going to teach you a few basic commands to get you started. So often, if you're using like a graphical user interface, you might like double click on something and sort of be able to see all your different files and folders. And also, we don't call things folders, we call them directories in Linux. Folders is kind of a Windows name actually. But when I say directory, think folder. So I can see all the files and directories here, and I can double click on things. Right, this is maybe what you're more used to when you're navigating through files. All right, on the command line, how do we do any of this? I might make this a bit bigger. Well, the first command is ls. It stands for like list. Give me a list of all my stuff in this home directory. I've got lots of, I hope I don't have anything embarrassing. Yeah, so here I've got lots of directories. Okay, how do I then go into a directory? So, somebody's calling out CD. Yeah, that's right. So I can type CD, the name of the directory that I want to go into, and I can see first of all, I can see down there that this prompt has changed. It's telling me where I am. I'm in this particular directory. I can do an ls. I'm just thinking if I want to do that. And I could list all the files. Yep, okay, that's all right. There's not much in there. So what I might do, if I just type cd on its own, I'll be right back in the home directory. So typing cd is just like pressing like a home button. I'm back to here. Now, if I actually want to make a new directory or folder, there's a command called, and these are all in the slides, yeah, mkdir, make directory. And I just give it a name. I'm going to call this COMP1511 lecture, all right? And it might look like nothing's happened. Typically in Linux, if you don't see anything, that's good. It means there's no errors. It's only going to print something out if there's an error a lot of the time. If I want to go into that directory, like the equivalent of like double clicking on it, I say cd COMP1511 lecture. I'm in there, there's nothing in there, right? I've just made that directory. How could I make a file? I'm hearing some great suggestions. I'm hearing touch, code. There are a few different ways to make a file. Typically in this course, we're going to be using an editor called VS Code. Has anyone heard of it? Okay, cool. We've got it set up here. To use it, we type code. And if you haven't used it before, that's fine as well. It's just an editor. Hello. Yeah, so we type code. I want to make a file called food.txt. It's open this editor, and I can start typing in it. For example, now if I see this circle here, can everyone see this okay? Is it big enough at the back? If I see this circle, it means I haven't saved it. So I can either go File, Save, or I can just press Control S, and then I've saved it. So I've just created a file, and I can see it if I do ls. I can open it again later and continue editing that file. All right? Now, don't worry about remembering all of these Linux commands the first time you've heard them. All right? The other things you might want to do, okay, I might want to make a copy of a file. So I could use the command cp. I want to make a copy of this food.txt file and call it, I don't know what I'm going to call it, food2. I don't know why. So making a copy like this, I've now got a copy of that file. I could decide, yeah, food2 is a pretty bad name. I'm going to change the name so I can rename the file using a move command. So I can say, let's change the name of this to, I don't know, this, right? So we can use cp to copy, mv to rename a file. I can also use mv in a slightly different way. So I'm going to make another directory. Right? And I'm going to say, let's move food.txt into that directory. So this is a bit like dragging something into a folder. All right? So these are a few basic Linux commands to get you started. Again, you're going to be practicing these over the weeks, and you're going to get used to them, so don't stress. Print WD, that just means tell me what directory I'm in. It's not that important for us because we can see where we are in the prompt, right? Our prompt is telling us we're in this particular directory. You may notice this whole long thing here. Yeah?
How can I put a file to move it to a previous or higher level
We're getting a good question here. How do I move a file or something to a previous or higher level directory? So sometimes we might go up a directory. We might go to a parent directory. In Linux, the parent is ... So if I say, for example, cd ... that's like going up to a parent directory. So we'll get used to using ... to navigate all through the different system. So that's a really good question. All right. Yeah, when we do PWD, we see this whole long thing. This little tilde, which is our home directory, is shorthand for this big whole long thing that I would never remember. Yep. All right. There's a few other commands. I've shown you these ones. Oh, remove. Sometimes we want to delete files. Just a word of warning, it's not like dragging something to the trash bin where you might pull it out again later. It's going to really delete it. So just be careful. Think twice before you press enter. Let me go delete something, remove something. Now, since this is not the most useful file, I feel safe to press enter now. I'm just going to remove it, and it's gone. Okay? That's how you can remove files. Now, if I try and remove this directory, it's going to say it's a directory. It's also got stuff inside it. I can do something which is pretty powerful. Oh, I'm trying to remove it. I'll remove it in a minute. There are flags that you can add to these Linux commands to make them do slightly different things. So we can add the -r flag and recursively copy a whole directory, or if we're brave, recursively delete a whole directory. Okay, so I'll just quickly show you that. So I could copy this whole directory and all of its contents by doing cp-r. Okay, and I could remove one of these whole directories. Again, be careful doing this by using rm-r. All right, so that was just a bit of a crash course, and I don't expect you to remember all of that. And also, if you want to go and look at more though, there's a Linux cheat sheet. I've got the link to that. Okay, I've got some hands up. Yeah?
While you were writing stuff into the terminal, I saw that you entered / at the end of each line. What's the point of the /?
Oh, okay, I didn't have to. So I could have just said, and it would have worked, actually, yeah. Yeah, both works. And another question? Oh, sorry, the question was then, why did I type that /? And I didn't have to. Yeah, it works either way. Yep.
If you want to take a file out of a directory, do we also use the mv command?
Yeah, you can move it. Yep. That's right, to a different directory. Yep. So you're going to be playing around with these Linux commands in the lab this week. Yep, one more question. Yep.
Only move the directories other than the files?
Yep, you can move a directory into another directory as well using move.
Not the files. Before the files.
You can move a file into a directory. You can move a directory into another directory. You can move the name of a file and give it another file name. All that with the one command move. Yep, one more question.
When I was trying to delete a directory by using the rm command, it didn't delete normally. I had to use the -r.
That's correct.
So why is that?
So when you're deleting a directory, it doesn't just let you use rm. You've got to use rm-r to delete the whole directory and all of its contents. Or you can delete a directory with remove directory. Yep. But let's not go too far into all these specific scenarios at the moment, because We're just learning that these things exist, and then we're going to practice them. Okay, yeah?
Can we use code filing.c instead of .txt?
Yeah, exactly. So we just had a question, can we use code for like a file.c? And that's exactly what we're going to do now. Yep. All right. Awesome. So let's get on to some C programming. Just quickly before we do, I'm finally going to show you some C code. Why are we learning C? That's sometimes a common question because, you know, it's not always the choice for a first programming language. But there's some really good reasons for learning C. A lot of modern programming languages are based on a lot of the concepts that you're going to learn in C. So you'll be able to transfer those skills to other coding languages. But the real big thing is that C allows you to access memory directly. So you get a better understanding of the underlying computer and machine architecture. And that's what we want you to learn in this course. So you'll get to play around with memory or RAM directly in your program. That's usually hidden away from you in a lot of other programming languages. C is still a very popular language, even though it was created in the 50s or 60s. I don't know the exact, but a long time ago. I think it's in the top 10 programming languages, and lots of really serious code like operating system kernels of the 3 sort of major operating systems are written in C. I think a lot of Git was written in C. You know, it's a really cool language. But also, we really want you to learn the programming and problem-solving skills and logical thinking that you can then apply to any other kind of programming language. All right? It's not necessarily about learning and memorizing every fact about the C programming language. That's sort of not what we want. Okay. This is our first C program. Okay? And if you're looking at this thinking you don't know what any of it means, that's fine. That's what we're here for. So what I'm going to do, there's going to be lots of bad jokes and bad puns in this course. I will make my own one. Okay, let me go back to here. I'm going to go to a different location. Don't worry about where I'm going. As long as I remember where I'm going. Okay. All right. So I've got a file here already called Hello World. I'm going to open that in VS Code, and we're going to write our own program. So I've already got this thing here already. Now, some of you, if you've programmed before, you might know what this is, but this is called a comment. So a comment is for humans to read. It's not something that the computer's going to execute. It's there as documentation. Why might we want comments?
So we can write something inside the code.
So yeah, somebody said, so
For the programmers to read.
yeah, for the programmers to read. And what will you say?
So we can write inside the code
Yeah.
if you want to write something in structure or something.
So we can write sort of our own notes to make things easier in the code. Yeah? Did you? Okay. So yeah, this is documentation. So when we sit down tomorrow or in 3 weeks or in 2 years, we know why we wrote the program, what it's meant to do, and we've got other documentation to help us if we wanted to modify it or run it or whatever. It's also for other people. So if you have a job, your colleague might have to open up your code and change it. So you've got to make sure you have it in a way that's readable by other humans who have to change it. In this course, it needs to be readable by other humans who are your tutors who are going to be marking your code. So it's really important for it to run and work, but also be readable for humans. And commenting is one important way to do that. This one at the top of our program, we call this a header comment. And often in your labs, you might write that it was written by, you know, whatever your ZID is, and like the date, whatever the date is. You'll do it properly, unlike me now. So that's your header comment. Another way to do comments is like this. You can do multi-line comments like this. Okay. All right, what about code that we have to write for the computer? Well, every single program is going to have a main function. And at least for us in this course, for the first part of the course, oh yeah, I haven't done an include. That's true. For this part of the course, we're always going to have a main function that looks like this. Int main void, curly bracket open, curly bracket close. Now, we're not going to explain to you what that actually means properly just yet, because you haven't learnt enough to fully understand what it means, other than that every program has to have it. You can't spell it wrong. Well, you can, but it's not going to work. It has to be called main. Don't be creative. Don't change it to like anything like that. It's just got to be main. The other thing it has for this part of the course is this thing. We're always going to have this return 0 at the bottom. Again, we're not going to explain exactly what that means. For now, you're always just going to type this stuff in and write the code somewhere in here. Now, return 0 actually is something to say, oh yeah, this code executed successfully. Later on, we might be returning something else, an error code to say, uh-oh, something went wrong. But for now, we're not there. We're assuming our programs are all working brilliantly. Blah, blah, blah. Did someone have their hand up? Oh, a few people, yep.
I'm just curious. Does this work kind of like isn't it with C#, where there's like main void and there's void loop? So when you put something in a void loop, it sort of loops it goes over and over again.
Okay, so someone's asking about looping, which we're going to get to in a couple of weeks. There are some crossovers with C#. I think that's what you said.
I forgot about that.
Yeah, but yeah, we'll be that. All that sort of stuff's coming up. Not on the first day though. Yep.
I just want to be sure about one thing. If we don't write void and we just leave it like that, does it make any impact on any other code that we write?
So someone's asking, can we do it like this?
Yeah.
You probably can, and it will probably compile and work.
For every code that we write?
But look, it's better to do it like this. There are some subtle differences that probably won't matter in most implementations, but yeah, it's better to do it like that. All right, so say we want to, this is the template for sort of all of our programs. Now, in this program, we just want to print something out. To do that, I use printf. But to use printf, that's part of a library called the std.io library. So pretty much in every single program you're going to write in this course, you're going to put this line here to say, please include, it stands for the standard input-output library. So pretty much all of our programs are going to be taking input or giving output, so we're always going to be using it in this course. So again, this is something you're always going to do. Now in this particular program, I want to just print out, typically the first thing you see in a course is something like hello world. Right? So I can save this. And this should be a working C program. How am I going to run it? Does the computer understand this C code? It doesn't understand C code. So yeah, I can hear lots of good suggestions. Yeah, we've got to turn it into an executable file that the program can understand. So to do that, we can use a compiler. Now, you might have used compilers if you've done any C programming before, or you've seen a GCC compiler or a C-lang compiler. There are other compilers. If you've never heard of a compiler, that's okay too. we're using DCC. It was made by lecturers at the computer science department at UNSW here. It's designed for students. It gives really helpful error messages, and it does a lot of safety checks that help us when we're learning to code. So we're going to use that. How do we run it? Well, let me just show you. So I can just type dcc hello world. And the good news is it didn't print anything out, which means there's no errors, which is good. Now, if I do an ls, I can see this weird file. You may not be able to see it properly. It says a.out. That's my executable file. Now, you might be sort of used to double clicking on things to run things. But to run it here, I say /a.out. So the name of my executable, this is how I run it. And it prints out hello world. All right, amazing. You can go home and impress your family and friends. Now, one thing about this is I don't like the way that this world and my prompt is right next to each other. It's annoying me, right? I want a new line. So I want to put hello world, then a new line. Yep. Oh, wow, some people already know some of this stuff. I did show you the code. /n. That stands for new line. All that does is put a new line in. So now, I should try not to cover this up too much. I can compile it again. So keep in mind, everyone, this is important. Every time you change your code, one, remember to save it. That's an old, lots of people do that. They think, what have I done wrong? They haven't pressed save. But you also need to recompile it if you've changed it. All right? Then you can run it, and it should have a new line, right? And I can keep running it and running it and running it, but if I want to make a change, I have to save and recompile. I could go and change it to hello COMP1511 and COMP1911. I have to save it. I'm pressing Control S to do that. I have to compile it. And then I can run it. Now, the other thing is I might not want my executable to be called a.out. Especially if I'm making lots of programs, I don't want them all to be called a.out. I don't want to have to keep using the move command to change it. So I'll just remove this a.out to get rid of it. But when we use DCC or any compiler, I can tell it what to name my file. So instead of just writing dcc-hello-world.c, I can use this -o flag and say, actually, this is what I want you to call the output or the executable file. I can give it any name I like. It's best to give it a sensible name so you know what it is. Yeah, so now I can just name my programs whatever I want, and then I can find them easily and run them easily. All right, we've got a question, yeah?
For DCC, like we use it in UNSW, but we used to use make, blah, blah, blah.
Someone's asking about a make file. We're not doing make files in this particular course. That's something else that can control compilation of things. We're just going to stick with DCC on its own like this. Now, I've made it look very, very easy, or maybe I haven't, but hang on, I'll get to you in a second. When we compile, things don't always go that smoothly. Often we've made a typo. For example, I'm doing this on purpose, but we might have left this semicolon off. So at the end of all of our executable statements, we have a semicolon. Now if I do DCC, it's going to give me an error message. Now, in my opinion, this error message is really good and useful. So if we have a look here, it says, this is saying the error message is on line 15. Line 15, yep, that's where I know that I purposely got rid of that semicolon. It's saying it's in column 44. So the column, there's a counter. I don't know if you can see. Let me just get this pen out in case. So over here, we've got our line numbers. Over here, it's saying what column I'm in. And it's saying 44. So the error message has told me line 15, column 44, we're expecting a semicolon. So to me, that sort of error message is quite helpful and clear. And you're going to see this error message quite a bit. All I do is I go put that semicolon in, I press save, and I hope that when I compile it again, it's not complaining at me anymore. All right? Sometimes the error messages aren't so easy to understand. Let me try this. I just got rid of this open brace. This one is a bit more confusing. It's not really telling me go type in a bracket on line 14 at any particular column. It's quite cryptic. Does everyone agree? This is a confusing error message. Sometimes you might get a confusing error message like this, and you might not be able to work out what it's asking you to do. Obviously, in labs, you can ask your tutor. We've also got this thing called dcc-help. So dcc-help, I can run this, and maybe it can give me a more detailed discussion of what's wrong. And this is a lot of text to read, but yeah, it's telling me about curly braces, and it's giving me more information to help fix this. So we've got these extra tools, dcc-help, which can give you more help with your error messages. And if that still doesn't help, we've got something called dcc-sidekick, where you can go into a bit more of a conversation. So if I run dcc-sidekick, I can open up the web browser. It's taking its time today. Doesn't usually take this long. Oh, page unresponsive. In theory, when you run dcc-sidekick, it opens up a little chat thing and you can ask more questions. So try it again. I'm not sure what's wrong with it right now. But yeah, typically it does work. Let's try one more time. Cool. Again, you can play around with these things in the lab. Just one word of warning. Oh, yeah. One word of warning, dcc-help and sidekick are there for you to use during the term when you're learning. They won't actually be in the exam. DCC is, but these ones that help you work out the error message, they're to help you along the way while you're learning. In the exam, you won't have them. Yep, a question?
Is it considered like AI, like plagiarizing in your assignment?
No. So this is a good question. dcc-help and dcc-sidekick are using ChatGPT to give you better help with your error messages. Now, there's a big difference between getting help correcting, a semicolon or a missing bracket in code you've written to getting something to generate a whole assignment for you. You know what I mean? So we're allowing you to use dcc-help and dcc-sidekick to help you with your assignments. What we don't want you to do is to go into ChatGPT and get it to generate all of your code for you. Yeah, do you know what I mean? So if it's just saying, oh, you've left out a bracket, fine. If they produced 500 lines of code that you copy and paste, not fine. Yep.
When you create an alias for the, when you dcc-hello.c-o and then the name you want to run it with, you don't have to delete that
No. So the question is just about using DCC -O. It just overwrite, every time you do it, it'll just overwrite whatever that file was. You don't have to delete anything.
So if I create multiple aliases with hello world -1, 2, and so on and so forth, if I leave it as it is and close the program, will those be saved or will they terminate?
You can do DCC and make as many programs as you like, and they're all just files that will be there when you come back later and that you can run them. I just want to show you one more thing before we go, because this will be one of the lab questions, I think, this week. So you've seen that \n means new line, and we call \/ an escape character and \n an escape sequence. You don't have to remember those names necessarily. And we have things like \t, which is a tab. \quotes. Why do you think we need a \quote?
When you want to add inverted commas.
So if I try and print out something like this, if I actually want to print out quotes, C gets confused because it doesn't know the difference between the quotes I want to print and the quotes that I always have to put around my printf. So to tell it, I really just want you to print out, and if we try and compile it, it's not going to work. Oh, I didn't save it. So what we can do is put this \, and it says, I actually just really want you to print out this quote for me. The quote doesn't have any special meaning, just print it out. Okay. What about if we wanted to print a \, though? Yeah, \2 is a special character. If I want to print one \, I have to put 2 in to say, no, this \/ doesn't have any special meaning, just print a \. So this can look a bit cryptic when you're trying to print these sorts of characters. And you're going to see something like that in one of the lab questions, all right? If you found that last slide confusing about the escape characters, don't worry, you're going to cover it again in the tutorial and lab. Okay, that's pretty much it for today. Just a reminder that programming definitely requires a lot of practice. Reach out for help when you need it. And don't forget, ask on the forum for content, email us for admin. Come and talk to me now if you need to. And bye everyone, thank you.